My name is Daniel Doherty. I'm a junior at Bucknell University. I'm majoring in history and geography, and I'm from Horsham, Pennsylvania. I am looking at African sleeping sickness, and I am comparing it with climate data to figure out, how is sleeping sickness going to be impacted by climate change. And so to do this, what I have to do is figure out where the tsetse fly lives, and the tsetse fly is the insect that spreads sleeping sickness. And so if I can find the habitat of the tsetse fly, I can figure out, okay, this is where sleeping sickness will be most common. And then with climate change, how that impacts the habitat of the tsetse fly, I can determine where exactly the sickness will be in the future. Yeah, MaxEnt is a program that models species distribution with climate. And so the way to do it is you need a spreadsheet of one species or many species, depending on how many you're analyzing. You need locational data, latitude and longitude. And you import this spreadsheet into MaxEnt. And then you import climate data, which are, I believe they're raster sets.
Where are the climate data sets from?
Worldclim.org. And so you import these climate data into MaxEnt, and then you have the spreadsheet. You run the simulator, and what it will do is take the locational data, and then it will take climate data from those locations, and figure out, okay, which or what climate is the tsetse fly or whatever species you're doing. What climate does it prefer, based on your locational data and the climate that it gives you. And so it'll output a raster file for you, showing probability 0 to 1 on a like a stretched sort of color output, and it'll show you which areas are most likely to have the tsetse fly and which areas are least likely. And so to model future climate data with that, you would simply do the same process, but project the current climate data on top of a future climate data. So the program can take the current data and then compare it to the future data you're projecting it to, and output a new map showing where the fly might live in the future. There are two types of sleeping sickness. One, the Gambian sleeping sickness, is mostly found in West Africa. And in southeastern Africa is where we find the other type, Rhodesian sleeping sickness. Both are very similar. Rhodesian is a little more potent. But based on what I've done so far, I've realized that sleeping sickness is going to be, in some areas, completely eradicated thanks to climate change. But with climate change, there's a possibility that if the tsetse fly was introduced into an area like Southeast Asia or Australia, there could be disastrous consequences, because with climate change, these areas become prime habitat for the tsetse fly. This is my first experience with GIS, and it has been just great. I mean, it's an awesome program, ArcGIS. So much you could do with it.